اصبر عصام اصبر البلوكر
يمشي ليه ندير إشارة
اصبر عليك نغلق منها وين
دوك فروم دوز
اغلق هذيك معليش هذه بدك كم باس هذه نزيد اغلق هذه نورمالمون سلام سلامة لا معليش لا نعمل موي شي ما بقاليش لي فورتي هي صح البريزونطاسيون ليش مازال ما فيها البريزونطاسيون معليش
كاين اسمه شابو كاين عندنا طريقه
L'essentiel, c'est la discussion. D'accord. Monsieur Rahmani Sofiane Taki-Eddine, vous allez présenter votre travail intitulé Évolution spatio-temporelle de la sismicité de la région Nord-Est algérienne dans le cadre de votre thèse de doctorat en 11e cycle LMD devant le jury ici présent. Donc vous
I'm honored to stand before you today to present my PhD work titled Spatio-temporal Evolution of Seismic Activity in the northeastern part of Algeria. I would like first to express my sincere gratitude to the member of the committee for the time they have provided during the examination of my thesis. Also, I want to thank my colleagues, friends, and family for their attendance today. So, sorry for the technical problem. So let's address for a moment the natural disasters that we experience in the world, such as tsunami, landslide, and of course, earthquake, which is the subject of this thesis. These disasters have a significant impact on our society. Therefore, understanding their pattern is crucial for hazard mitigation. As researchers, we conduct investigation. And when we think about investigation, we directly think about detectives and crime. So I thought about a funny analogy today where the crime is the earthquake, the victim is the society. As researchers, we use tools or develop new ones to investigate this phenomena. And of course, our crime scene is the northeastern part of Algeria. So these earthquakes are generally generated by external factors, such as tectonic loading, fluid intrusion, static or dynamic stress transfer, slow sleep, and also it can be a combination of all these factors. So to understand which of these mechanisms is responsible for earthquake occurrence, we need three crucial informations. Earthquake data, which is the earthquake catalog, the spatio-temporal models, and a complete understanding of our region. The combination of these three informations will help us more understand the behavior of earthquakes in time and space. Let's start with the tools, which are the spatio-temporal earthquake pattern models. But before that, let's talk about one of the most important parameters, which is the magnitude of completeness. One may ask, what is the magnitude of completeness? So it's basically the magnitude at which we are, let's say, 90% sure that we have detected all earthquakes. Because even with the constant evolution of the technology, we still can't detect all earthquakes. Sorry. Sorry for this second technical problem. So I said the magnitude of completeness is basically the magnitude at which we are 90% sure that we have detected all earthquakes. Because even with the constant evolution of technology, we still can't detect all earthquakes, especially the smaller ones. And this is primarily due to technical problems or natural causes. So here's an example of the earthquake catalog where you can see that the earthquake catalog from 2006 to 2020, and where you can see that the detection rate is not stable in time, and this problem should be taken into consideration. So fortunately, there are methods that can be used to estimate MC. Starting with the first and simplest one, which is the maximum curvature, where MC here is the magnitude that has the highest peak in the non-cumulative distribution of magnitudes. The second method is the goodness of fit, and as its name suggests, we simply calculate the absolute differential between the observed and synthetic magnitude distribution. NC is the magnitude that has the lowest residual. The p-value stability, so the parameter p-value, we'll talk about it later. So here MC is the magnitude that has the lowest change between two consecutive p-values. And finally, we have the entire magnitude range, where here we aim to characterize the whole magnitude distribution, including the incomplete part and the complete part. So we should point out that these methods are generally used to estimate MC for a catalog as a whole. But as we have seen in the example before, changes in time can occur. And one problem in particular should be taken into consideration, which is the short-term incompleteness, where at the beginning of the sequence and after a large earthquake, small events tend to overlap with bigger ones. So Helmstetter developed a relationship between the magnitude of the main shock and MC to detect this period of incompleteness. Also, Hensel tried to estimate MC with the seismic activity rate. So now that we have talked about all the magnitude completeness technique, let's get into our model, pattern model, starting with the magnitude distribution analysis, which is generally done by the Gutenberg-Richter law. So this law simply characterizes the frequency of earthquake according to their magnitudes, where the logarithm of the cumulative number of earthquake is equal to A minus Bm, and B in the magnitude, A and B are constant. So the B value determines the relation between the frequency of small and large earthquake from a mathematical point of view. But from a physical perspective, it acts somehow as a stress meter, since it's inversely proportional to the stress state. The parameter estimation is done either by least square regression, even if it's not really recommended, or by maximum likelihood estimation. The A value determines the activity level, and its estimation is the same as for the B value. Now getting on the temporal distribution of earthquake and starting with the aftershock temporal decay by the Omori-Utsulu. Here, this function simply expresses the aftershock decay after the occurrence of a large shock, where the rate of aftershock is equal to K by T plus C power P. T being the time relative to the main shock, KCP are constant to be determined. Also, this function can be used to predict the number of aftershock in a certain period of time by simply integrating this function. So, if we take a closer look at each of these parameters, we have the p-value, which controls how fast is the decay, the k-value, the productivity of the main shock, and c-value, time lag between the main shock and the start of the decay. Because in theory, we assume a linear decay of aftershock after the occurrence of a large shock with C equals 0. But in reality, no, C is not equal to 0, and this is primarily due to short-term incompleteness. The parameter estimation is done by a nonlinear inversion by maximum likelihood function as a cost function. Another way to study the temporal distribution of earthquake is the inter-event time analysis here by gamma-like probability density function. Here, two parameters are important: the background rate, which expresses the frequency of independent events, and the branching ratio, which is the fraction of aftershock in a study catalog. So if we take a closer look at this synthetic distribution of inter-event time, we can clearly see that the short inter-event times tend to decay according to 1 by delta t, in contrast to larger ones that have more of exponential shape decay. Getting on the big one, which is the temporal ethos model, or the epidemic type aftershock. Here, the ethos model assumes that each earthquake can trigger its own earthquake, and its mathematical expression is composed of 2 parts: the background rate, which is assumed to be constant in time, and the aftershock triggering rate, which include the productivity of the aftershocks and the Omori-Utsu function. Here's an example of a predicted ethos rate for a synthetic catalog. So here, if you want to make a simple physical analogy to this model, we have the constant background rate is related to the constant external forcing, which is the tectonic loading, and the aftershock triggering rate to the earthquake triggering caused by static stress transfer. But one may ask, is the external forcing is always constant over time? The answer is simply no, because in some cases we have transient external forcing, like, for example, when fluids are involved. Here's 3 examples for variable background rate in time. We have the constant one for tectonic loading, the Omori-Utsu shape one for fluid intrusion, and the Gaussian shape for slow slip events. So Marson updated the ethos model and included the variable background rate in time this time. And so here the parameter estimation is done by semi-parameter conversion, where we estimate the ethos parameter with a constant background rate, then we calculate the background probability according to this parameter. This background probabilities will be used to estimate the background rate, and finally we smooth this background according to the Akai criteria. Of course, we have to repeat all these steps until the convergence. Getting on now to the spatio-temporal distribution of earthquake and the spatio-temporal ethos model. Here, the background rate is variable in space and constant in time, and the aftershock triggering rate is variable in both space and time. The background rate is characterized by a Gaussian function, including the background probability. The aftershock triggering rate includes the productivity function, the Omori-Utsu function, and an isotropic kernel density for aftershock location, where Q controls the decay of earthquake, D and gamma values controls the magnitude-dependent weight of the kernel. Here also we can ask if the isotropic model is a good approximation to earthquake location. The answer is also no, since we can, for small or moderate earthquake, assume an isotropic distribution of earthquake, since we do the same for source parameter estimation, where we assume a circular source. But for large earthquakes, aftershocks tend to occur along the rupture length. And here the anisotropic model is more suitable, since it includes this information. Also, the ethos model is used to decluster a catalog. What is a declustering? It's simply separating the background event from the clustered events. We have also another way to do declustering is the nearest neighbor, where we use the proximity of earthquakes in time, space, magnitudes domains to separate the clustered events and the background events. Now that we have talked about the spatial, let's take a brief moment to talk about the physical model, starting with the rate and state friction model. Here, where DHH bridged the gap between the rate of seismicity and the stress rate. Also, he made a great analogy with the Omori-Utsu, where he predicted the non-zero value for the C parameter and assumed its relation to the stress changes. We have also the Coulomb failure, where we assume that each material will fail if the shear stress exceeds a certain threshold. The time that it will take to surpass this threshold is called time to failure. Recently, Dam and Hensel improved this model with the time-dependent stress response here, including the mean time to failure, and this model has proven to be more effective for characterizing induced earthquake by water infiltration. Okay, now we have seen that these models are really great for characterizing earthquakes in time and space. But if we don't do a proper data preparation, models can become useless. So Let's take a moment to talk about the data, starting with the earthquake catalog. It includes basically the earthquake time occurrence, the spatial location, and the magnitude. Here, we have to know that the magnitude estimation and location should be well constrained, since error can induce biases to our models. Other problems also exist and are more inherent to the methodology, which are the declustering, completeness magnitude biases, impact of a seismic forcing, and spatial biases. So let's start with the impact of the clustering on the p-value. Here, to showcase this problem, we simply generated a synthetic catalog using the ETAS model and with the p-value equal to 1. Then we declustered this catalog according to the ETAS model, the NND, the Riesenberg, and Gardner-Knopf techniques. We proceeded after that to the magnitude distribution analysis, where we estimated the p-value. Here, we can observe that the p-value for the ETAS catalog is nearly the same as the full one, in contrast to the Riesenberg and NND, where we observe a slight decrease of the p-value. However, the Gardner-Knopf catalog underestimate heavily the true p-value by a factor of 0.12. And since you know that the p-value is an important parameter to forecast the maximum magnitude in a region, we use these different p-values to generate 10,000 simulations and draw the probability density functions for each of them to the forecasted maximum magnitude of this synthetic catalog. Here we observe that the Gardner-Knopf one is shifted to the right, indicating overestimation of the true maximum magnitude. So let's talk about this problem now. In conclusion, I have seen that the clustering can lead to underestimation of the p-value, and this is primarily due to the fact that now we still don't lack from an objective criterion to distinguish between this is a main shock, this is an aftershock, or this is a background event. And all this is why nowadays modern probabilistic seismic hazard assessment includes aftershock in their estimation. Let's get into the magnitude completeness biases. Here, starting with the sample size, because we have to know how many data points we need for the estimate to estimate MC. Here we generated different synthetic catalogs with different sample size. Then we estimated MC using all the catalogs have MC equal to 2. Then we estimated MC according to the techniques we explained before. So for the maximum curvature and the goodness of fit, both techniques underestimate the true MC. The entire magnitude range overestimated for smaller sample size, but tend to recover it for larger one. Finally, we have the p-value stability. Here, the MC is underestimated for small sample size, but can recover it for larger one. This example is only here to showcase the importance of the number of data points. Let's get now to the time variable and completeness. Here, we generated 3 synthetic catalogs, one having a incompleteness from 0 to 0.5, one having a period of time of incompleteness, and one with a short time incompleteness after each large shock. And then we estimated the ETAS parameter for each of them. The first one, we observed the decrease of the K value and increase of the C value. Here, we can resolve this problem by simply adjusting MC to 0.5. The second case and third case, we observed the decrease of the alpha value and increase of the C and K value. Here, also for the second case, we can adjust MC to this period of incompleteness, and for the last one, we can simply exclude this short period from our estimation. Other solution also exists, one for the long-term incompleteness and one for the short-term. Starting with the long-term, misery all included in the ETAS model, the relationship between the expected number of event triggered by an observed event and by an unobserved event to the ETAS model. We tested this model on a synthetic catalog that had 3 levels of incompleteness and compared it to another one where we estimate the ETAS parameters for the minimum MC in this catalog. Here are the results, and you can see the black squares represent the true parameters, the red circle, the new model parameters, and the blue circle is for the ETAS parameter using the minimum MC. So here we can clearly see that this new model can recover the true ETAS parameter better than choosing the lowest magnitude of completeness. For the short term, Hansel made a relation between the apparent rate and the true rate linked by blind time, also with apparent frequency magnitude distribution and the true one. This was included to the ETAS model. We tested it on a synthetic catalog that has short-term incompleteness and compared it to the conventional ETAS model. So we can clearly see that this new updated version fits better the data than the conventional one. Now, getting on the impact of a seismic transient, here also we generated 3 synthetic catalog, one having a constant background rate, one with the Omori-Utsu background rate, and one with the Gaussian shape. Yeah. Then we estimated the ETAS parameters using the conventional ETAS model and the non-stationary one. So for the first case, we observed that both techniques recover the true ETAS parameters, in contrast to the second and third one, where only the non-stationary ETAS model recovered the true parameters. And also the conventional ETAS model in these 2 cases underestimate heavily the productivity factor. So here the problem is that when there is a variability in the background rate, it can lead to an underestimation of the true productivity factor. And this can be problematic when studying cases like when fluids are involved or swarm type activities. Finally, we have the spatial biases. Here we have 2 problems, like neglecting the anisotropic distribution can lead to underestimation of the productivity factor. Also, the ETAS model assumes an infinite spatial extent, which can result to unrealistic distant triggering impact for smaller events. Here, the solution is simple. We include an anisotropic function into the ETAS model, even if now it's still really complicated to do that. Also, we confine the distribution only to the rupture length. Here's 3 examples, one for a moderate earthquake with anisotropic kernel density, and 2 for anisotropic with magnitude 6 and 7. Okay, now that we have talked about the models and the issues, let's get into the main findings of this thesis. Starting with the study of the Abnirman earthquake sequence, which occurred in 2010 and in the intersection between the Bibans and Hodna Mountains. This sequence was characterized by the occurrence of 3 large shocks in less than 10 days, and also has produced several numbers of earthquakes. And since it's one of the significant sequences that occurred in the past decade, many studies have been conducted, starting with a study by Gilles, where they assumed that sequence was generated by 2 main faults, one oriented north-northeast and south-southwest, and one oriented east-west. Also, a study by Biljudi et al. Affected each of the earthquakes to its own fault and also estimated the source parameters. Abbas et al. Conducted a statistical analysis, but since they didn't take into consideration variability in the magnitude of completeness, these parameters could be biased. They also estimated the source parameters. We have also Biljudi's study in 2020, where they studied the interaction between the 3 large shocks by static stress transfer. Also, Abbas et al. Conducted a tomography where they identified the fluid reservoir as a main finding. We reproduced this tomography using the complete data set of the Abnirman sequence and observed fluid migration after the occurrence of the 3rd large shock. This work has been published on Journal of Seismology, where I was a co-author. And finally, we have the study by Hamdesh, where also he conducted statistical analysis, but didn't take into consideration variability in the magnitude of completeness. So here, what can we do to enhance our comprehension of this seismic sequence? What will be our contribution to this research? Let's start by identifying the problems and finding the solution. First, we have the problems that we need to know that after the occurrence of the first large shock, 1 day after, a mobile network was installed. This is maybe great, since with this mobile network we can detect small earthquakes. But for someone who conducts a statistical analysis, this can be problematic, since it can induce variability in the magnitude of completeness. So here, we redid the detection using only the permanent network, and redid also the location. We then estimated the magnitude of completeness using the 4 technique explained before, which gave MC equal to 2.1. And finally, we detected these small periods of incompleteness after each of the three large shocks using the Helmstedt relationship. Now, we get to the the results. We're starting with the magnitude distribution analysis. The p-value found for the complete sequence was equal to 0.87, which is a low value since it means that this region is under high stress. We divided the sequence into two phases according to the cumulative number of earthquakes. The first phase has a lower p-value, and in contrast to the second one, which means that the stress decreased after the occurrence of the third large. Also, we estimated the Omori-Utsu parameter for the complete sequence and predicted the constant rate for nearly 5 days, which is a high value compared to typical ones, but this is primarily due to the occurrence of three large shocks, which didn't, let's say, the sequence die properly. We also here divided the sequence into two phases. The first phase has a linear shape decay compared to the second one that has also constant rate before transitioning to the power law decay. We also conducted an inter-event time analysis. Here the background rate is equal to 1.36 and the branching ratio to 0.65, indicating that 65% of this catalog is composed of aftershocks. To study the variability of the background rate in time, we use the moving window with a 100 event length. And here's the result. So we can clearly observe that the background rate is not stationary and the peak is observed after the occurrence of the third large shock. We also wanted to fit our distribution with different probability density functions, including the log normal, the Weibull, and exponential. The log normal represented with the blue line fits better the data than the exponential one, indicating high clustering of this sequence. We also estimated the ETAS parameter with and got a low productivity factor equal to 0.51, which is odd since this value is typically found for swarm activities. Also, if we take a closer look to the transform time, we can clearly see that the ETAS model misfit our observation before and after the occurrence of the third large shock. We also here used a moving window to estimate the background rate by fixing the ETAS parameters, and the shape here of the background rate is nearly the same as for the inter-event time analysis. For the spatio-temporal ETAS model, here we have only one main result, is that the background rate is mostly concentrated on the north, northeast, and south-southwest segment, where near the third large shock. Finally, we have the non-stationary ETAS model that gave a better fit than the conventional one. Also, the background rate has a similar shape to previous technique that we used, which is the inter-event time and ETAS model. And also, we can see a peak of the number of background events after the occurrence of the third large shock. We declustered this catalog using this non-stationary ETAS model and divided the phases like we did for the Wittenberg-Richter and Omori-Utsu. The first phase has mainly events with the low background probability, and the second phase has events with a high background probability. So from this result, we decided to redo the tomography. So for the first phase, we have the earthquakes are mainly located in the east-west segment and are composed of aftershock mostly. And the VPVS is low according to the tomography. The second phase has most events located in the north, northeast, and south-southwest segment, and is composed mainly of background events. Also, the VPVS ratio was found high in this phase according to the tomography. So, from the result that we got, we assumed that this sequence was generated by three main factors: tectonic loading, fluid intrusion, and static stress transfer. A proper interpretation is that the sequence started as a typical main shock aftershock, then after the occurrence of the third large shock, fluids were involved, which clearly explain the increase of the seismic activity. This work has been published on Geophysical Journal International, where I was a main author. So, From the results that we had and the spatial temporal behavior of this sequence, we can clearly observe that it exhibits characteristics more akin to swarm-type activity. Since you may know that seismic sequences are categorized into two main groups. The first one, which is the main shock aftershocks, where we observe a large shock at the beginning, followed by a decay of aftershocks. We can sometimes observe some small event called foreshocks. We have the second type, which is the swarm type, where we observe high clustering of events in time and space, but without a clear main shock. Also, we can observe a succession of main shock aftershock sequences. So this observation led us to conduct another work, which is the detection and characterization of earthquake swarm in the northeastern part of Algeria. Here, we used the CRAAG data from 2007 to 2020. We divided the region into grid cells. For each of these grid cells, we calculated, of course, the magnitude of completeness and choose the highest one to avoid any biases. To detect the swarms, we use primarily two methods. The first one is the 1 sigma criterion, where we estimated the spatio-temporal ETAS parameter for the whole region using a bootstrap approach to quantify the uncertainties. Then we calculated the transform time in each of the grid cells using these parameters and applied the condition that for a swarm, the expected number of events between two successive events and for 5 consecutive events should be less than 0.382. The second method is use the seismic moment distribution in time. We calculated the skewness and kurtosis of this distribution and found the parabolic relationship between these two parameters. So here's one example from the first method where a swarm was detected in the 2011, and here's the parabolic relation between the kurtosis and skewness parameter. The pink squares represent the swarms, events, sequences, and the purple circles, the main shock aftershocks. So since these two methods nearly detected the same cluster, we merged them to create a more comprehensive earthquake swarm catalog that includes 32 clusters, I think, and represent 26% or 29, I don't remember what percent of the whole catalog. We estimated the p-value for this swarm catalog, but since it will be more meaningful to do it for each cluster, we didn't do proper interpretation. We analyzed this catalog and found that the maximum magnitude ranged from nearly 3 to nearly 5, from the number of events from 5 to nearly 200, and the duration from less than a day to nearly 120 days. Finally, we categorized these earthquake swarms into zones according to the geological and tectonical context. So here we are not going to talk about all the seismic swarms and only focus on the ones that already have been studied and the ones where I was involved in the analysis. Starting with the swarms along the southern and western borders of the Lesser Kabylien block, here we have one sequence detected, which is the Sétif crisis of 2017, where two parallel segments were found. These two parallel segments have channel type shape, and this type is generally assumed to be related to fluid infiltration. This work has been published on Geoscience Journal, where I was a co-author also. We have detected also the Lawana sequence, where we observed the spatial migration and the occurrence of two large shocks in January and February of 2020. But until now, no proper mechanism was found, and even after conducting the tomography. The analysis of this sequence was also published on Pure and Applied Geophysics, where I was a co-author. Finally, also we have two seismic swarms detected on El Cantur region, one in January of 2020 and one in November of 2020 of the same year. So the later one has a large shock shifted a few kilometers to the south. So here we think that this shock was responsible in the generation of this cluster by static stress transfer. Also, we need to point out that a large shock also occurred in the same region in 2017. Finally, we have the Mila sequence of 2020, where two large shocks were observed in July and August. This sequence occurred on the Bni Haroun Dam, which is an important information that should be taken into consideration. A study by Boulahia suggested the involvement of fluid in the generation process. Also, these 4 swarms occurred in the same years, with 2 of them occurring in 1 month. So we can assimilate that to a chain reaction, maybe caused by dynamic stress transfer. Let's get now to the Mila-Constantine basin. We have the cluster. We have detected the cluster near the Bni Haroun Dam that occurred in 2007. A study by Semeniol assumed its relation to the relation between the water pumping and the increase of seismic activity. Getting on the Jaya Babur region, here we have detected the seismic sequence of Jaya Babur that occurred in 2012 and 2013. Study by Boulahia assumed that 2 mechanisms were involved: the static stress transfer and fluid intrusion. Also, tomography revealed the fluid reservoir in this region. Let's get now to the Hodna range. Here we have the Bni Haroun sequence, Bni Yilman sequence, sorry, and the Ain Lazel sequence. Since we talked about the Bni Yilman, let's get directly to the Ain Lazel one. Here, some side effects. So the Ain Lazel sequence occurred in 2015, where 4 large shocks were generated in less than 5 days. I studied personally this sequence in my master thesis, where 1,008 events were detected and located. So we assumed that this sequence was also generated by fluid infiltration, and the statistical analysis also assumed the same thing. Getting on the Central Italian Atlas region, here we have the Hammam sequence, where we observed of 2013 and 14. We observed also spatial migration, but this needs more detailed analysis to understand which mechanism was involved. We have the Mihub sequence, where studied by Khalif assumed interaction between the 2 large shocks by static stress transfer. Also, the study by Debouzeol on the Dia sequence assumed the interaction between the 3 large shocks by static stress transfer. Let's go now to the offshore Algerian margin. Here, many sequences have happened. One of them is the Gigel sequence of 2019. This work has been published, and I was a co-author. And since it was my first paper, it's like nearly your first kid. So a study by Yildiz, we have the seismic sequence of Algiers, studied by Yildiz where they studied the interaction between the 2 large shocks by static stress transfer. Also, we have detected the small swarm cluster north as a Fon region in a quiet place, even with the presence of major faults. And since swarms can be precursor to large events, we can maybe ask if there is a stress accumulating in this region. Finally, we have the Eures range. Here we detected the Ma'ber sequence as a swarm, but since we don't have many events to conduct a proper statistical analysis, no proper mechanism was proposed. So if you want to make a conclusion about this study, so we have many seismic swarms that have been generated by different mechanisms. Some of them are still unknown, since we don't and still needs more detailed analysis to understand which mechanism was involved, and so on. This work has been submitted to Natural Hazard, where I was the main author, and they take too much time to answer. So if we want to wrap up all this presentation in a few slides, you have the earthquake catalog, which is small information, but can give you many explanations about earthquake behavior. So this catalog should be well understood, since we're dealing with earthquakes and not only points. So then the location, the magnitude, the time occurrence should be well studied before conducting any statistical analysis. Finally, we have our models. We have to understand them, and we have to adjust them to what we want to do and what we are searching for. And this combination of these 2 information has led us to produce 2 main works: the analysis of the main seismic sequence and the seismic swarm detection. Why is it important to study seismic swarm? Since we may know that this type, which is the main shock aftershock, is quite predictable, since we know which mechanism is involved: tectonic loading and static stress transfer. Also, the aftershocks decay temporarily after the occurrence of a large shock. So we have laws that can explain this phenomenon. But this type, which is this one, is really unpredictable, since the largest shock can occur either in the middle or at the end. And the mechanism responsible for the occurrence of storm is variable from region to another one. So we have to study this type of sequences more, since they can be problematic for earthquake hazard mitigation. So as a perspective, we attempt to study each of the swarms detected individually, even at least the ones that we can, since some clusters have small number of events. Also, another study is being conducted actually with Sebastian Hensel from Potsdam University, where we are estimating the spatio-temporal ETAS model using deep learning, and as you can see, the first results are quite promising. Finally, PhD is not only about work and everything, it's also a human experience. And I think some people from the chat remember the field trip in Germany, where clearly I'm not a field type because I almost died there. Also with a group here of Sétif for the conference and everything. And also my PhD has let me know people from all around the world that I can call now friends, and which are with us now in the chat. So thank you for your attention.
Thank you for this nice talk. Merci pour cet exposé. Donc maintenant, qui paraît intéressant, qui va te juger maintenant. Donc on va passer directement au membre du jury, qui sont à ma droite. Je vais commencer par monsieur le jury. Je vous en prie.
Donc, je tiens à remercier M. Sétif pour l'excellent travail qu'il a réalisé, ainsi que l'exposé. Il a bien tenu de 40 minutes dédiées à présenter de son travail. Donc, je trouve que la thèse bien rédigée en anglais, avec un vocabulaire riche et correct. Donc, aussi, la problématique est bien détaillée, bien exposée, l'approche statistique de l'événement sismique, avec des recoupements, bien sûr, avec la modélisation physique, pour bien sûr présenter des modèles physiques afin de bien comprendre, d'essayer de donner des explications au modèle ou bien à la survenance des séismes, que ce soit par fort choc et après grand choc, bien on va dire séquence sismique, séquence, ou bien par directement même choc et activité after choc. Ma première remarque, c'est concernant, puisque la thèse est rédigée en anglais, le titre je le trouve en français, donc voilà, il faudra.
Non, ça c'est pour l'université. Le titre doit être le même que la proposition du sujet. Donc ils m'ont dit de l'écrire en français, comme la première proposition du sujet.
D'accord. Bon, juste première question. Bon, c'est vrai, vous avez maîtrisé l'anglais et tout, c'est bien, c'est une chose. Mais comment vous avez corrigé, qui vous a corrigé le manuscrit?
Non,
je l'avais soumis à...
Non, je l'ai écrit moi-même. Bon, j'ai utilisé quelques outils pour m'aider, mais en majorité, bon, c'est moi puisque j'ai...
L'intelligence artificielle avec...
Ah non. Parce que l'intelligence artificielle, des fois...
Non, mais c'est légitime. Hein.
Ah oui, non, aucun problème. Mais je ne fais pas trop confiance en l'intelligence artificielle parce que des fois, ça change complètement le sens.
Traduction de l'anglais en français, il y avait un peu... donc, surtout dans Bon, c'est des petits commentaires.
C'est l'intelligence naturelle.
Voilà.
Eh bien, ça me rassure, c'est très bien. Donc, juste une deuxième question. Bon, on parle ici de forecasting et de prédiction. Est-ce que vous pouvez nous expliquer le forecasting et la différence entre, bien sûr, la prédiction, la prévision, donc à quel niveau de recherche on est, quel est le niveau des sismologues, là même la science est bien arrivée dans ces deux.
D'accord. Donc, bon, je reviens à certains slides. Bon, ça. Bon, ce sera pour celui-là. Bon, déjà, si on parle de forecasting et de prédiction, c'est pas vraiment la même chose, puisque la prédiction, on essaie de déterminer exactement quand et où va se produire le sisme, ce qui est impossible maintenant. C'est pour ça que les scientifiques ont changé ça, parce que déjà, je me souviens d'une présentation d'un professeur où il a dit que les gens ont changé ce terme de prédiction, sont allés vers le forecasting parce qu'ils ont su que la prédiction, elle est impossible. Forecasting, c'est la prévision. Je vais vous donner un simple exemple, c'est, comment dire, par exemple, à cet endroit précis, dans ce bâtiment, dans cette région. Si on utilise nos modèles statistiques, comme par exemple le modèle ETAS, on inclut des sismes qui se sont produits déjà dans cette région. Ces sismes-là vont être utilisés pour savoir leur occurrence dans le temps, etc. Donc, on va voir s'il y aura une probabilité future, par exemple, on va dire de 0,03%, que dans cette région et dans ces cantons, il va y avoir un séisme de telle magnitude. Mais ça reste en termes de probabilité. Par exemple, comme ici, ici, c'est un truc synthétique, sur un catalogue synthétique. Là, c'est une probabilité. On génère des simulations. Par exemple, j'ai un b-value égal à 1. Un b-value égal à 1, je génère grâce à ce b-value des magnitudes sur plusieurs simulations, des dizaines de milliers, et de ce b-value, je vais voir quel est la pattern qui se répète le plus, quel est le pourcentage qui se répète le plus, et dessiner la probabilité que, par exemple, ici, on a 80%, plus que 84%, presque 90% pour cette âge, qu'il y aura un sisme de magnitude 3,5 dans cette région. C'est ça. Mais la prédiction, c'est beaucoup plus dire que ce point-là, à ce moment-là, il va produire un sisme. Mais ce qui est impossible, actuellement.
Et la prédiction, donc, à quel moment parce qu'il y a des recherches qui sont en train de se faire. Par exemple, est-ce que dans les 20 années à venir, on pourra prédire, je ne sais pas. Parce que c'est le but.
Voilà. Mais
le défi, c'est le challenge, c'est de prédire ainsi.
Voilà. Mais les dernières études, comme par exemple, il y a un article sur GRIM de 2021, où ils ont pu, en utilisant le modèle anisotropique d'ETAS, déterminer exactement pour la séquence de la Californie, prédire le nombre des répliques, la magnitude de la plus grande réplique et leur temps d'occurrence. Ce qui est déjà bien comme évolution, même si ça reste en termes de probabilité, mais c'est la plus haute probabilité. Par exemple, ils ont dessiné une probabilité comme ça et l'observé, ils ont comparé par rapport à ce qu'ils ont observé.
Et en termes de temps, est-ce qu'ils sont...
Presque la même chose. C'est presque la même décroissance des répliques. Mais quand même, ça reste en termes d'erreur, plus ou moins.
Donc, c'est-à-dire on pourra, d'ici les 20 années à venir, on pourra prédire...
Ah non, je pense pas. À ce point, jusqu'à là. Mais on peut au moins prévenir les risques. Ce qui est...
Généralement, bon, une autre question, généralement, bon, pour lancer ce genre de statistiques, il faudrait avoir un catalogue
bien
balèze.
Balèze, très balèze.
Mais ce n'est pas le cas pour les séismes.
Ah oui, très balèze, il faut
des... Si on prend le catalogue algérien, donc on commence à 412, 419, après on remonte jusqu'à 1365, après une coupure jusqu'à 1716. Et donc C'est-à-dire qu'il n'est pas homogène, le catalogue. Après, dans les années 80, les localisations, les trucs n'étaient pas aussi, jusqu'à l'avènement ou bien l'installation d'un réseau plus ou moins fiable,
Oui.
à partir de 2006-2007, un réseau numérique où on commence à avoir des catalogues plus ou moins
balèze.
Donc, mais dans ce cas de figure, par exemple, est-ce qu'on peut, pour remédier à cette problématique, que par exemple, puisque on est un petit peu dans l'ère de l'intelligence artificielle, d'homogénéiser en quelque sorte le catalogue et d'essayer de compléter, on va dire, les zones ou bien les lacs de temps qui sont, où il n'y a pas d'informations, et on pourra mettre des informations en les comparant par exemple à ce qui a été observé actuellement, et après relancer ce genre d'études, ce genre de fondation.
Bon, il y a aussi des techniques pour faire ça, pour remplir les vides, comme on dit, les vides où on n'a pas d'information. Il y a des techniques pour ça, mais il faut déjà avoir l'information. Genre, analyser où le catalogue est complet, à 100%, et générer des séismes à ces endroits-là pour remplir ces gaps. Mais ça reste encore un truc très difficile à faire.
Est-ce qu'on a essayé? Est-ce qu'on peut faire ça et dire...
Il y a des tests qui ont fait ça. Il y a des tests qui ont fait ça. Plus ou moins, ça se rapproche de la réalité, mais par exemple, ça, c'est pour les séquences typiques. Genre main shock, aftershock.
D'accord, donc une ou deux questions. Donc, par contre, sur la conclusion, j'ai pas vu un petit peu ce que je voulais. On est resté à notre fin. Il y a beaucoup de travail, il y a beaucoup de choses qui étaient mises en valeur. Mais je vois que M. Rahmani, il me parle toujours, par exemple, de ce qui a été fait, par exemple. La page 162, donc all that issue related to the impact of seismic transit. Tout ça, c'est des discussions et c'est des études qui ont été faites. J'aurais aimé les voir un petit peu l'introduction. Après, en conclusion, ça veut dire on devrait voir un petit peu ce qui a été réalisé. Et je trouve un petit peu la conclusion par rapport au séisme de Beni-Elman. On va dire que c'est le séisme le plus étudié.
Voilà.
La séquence sismique, donc pas mal d'études qui ont été faites sur ce séisme-là. Mais bon, je ne sais pas, ou bien je n'ai pas bien compris. M. Rahmani étale un petit peu les modèles qui ont été utilisés en évidence par l'approche déterministe. Et on vient parler aussi de, on va dire, de migration de fluides, d'hydrocarbures, je pense, par rapport. Mais M. Rahmani, donc tout ça, on ne voit pas un petit peu, il est parce que ça reste sceptique. Voilà, le modèle, c'est vrai, tel auteur a fait ça, tel auteur a fait ça, voilà ce qui a été trouvé, mais M. Rahmani n'est pas tangible dans ce.
Oui.
Voilà. Et voilà, donc ça veut dire, voilà, on ne trouve pas un petit peu. Même si c'est. Quelle est l'hypothèse par M. Rahmani par rapport
à la séquence sismique de 2000.
En dehors des statistiques, en dehors en termes de sismologie. Voilà ce qui s'est passé, voilà par rapport aux différents modèles, la migration des hydrocarbures. Et voilà, moi, c'est mon hypothèse.
Mais je pense que j'ai écrit cette hypothèse par rapport aux résultats que j'ai trouvés. Parce que ces hypothèses seront. Non, aucun problème. Oui. Bon, je reviens ici. Bon, en gros, toute l'hypothèse qu'on a eue est basée sur cette figure en elle-même, où on a quand même détecté deux phases distinctes. Une première qui est typiquement une séquence normale. On a des main shocks, on a une décroissance de réplique, même Omori-Utsu a une décroissance directe, etc. Donc là, on assume que le commencement a été normal, une séquence main shock after shock. Mais à un certain moment, des fluides ont surgi, je ne sais où, qui sont des hydrocarbures, et ils ont généré d'autres Ils ont généré plus de sismes. C'est ça l'hypothèse qu'on a donnée. Que c'est, en gros, il y a trois mécanismes qui sont responsables là. Le chargement tectonique qui a généré le premier séisme. On a le transfert de contraintes généré par ce premier séisme qui a déclenché les répliques. Ensuite, les fluides qui ont pris le relais pour le troisième choc et après. Voilà. Troisième choc. Et voilà. C'est ça l'hypothèse qu'on a. Mais moi, je reste sceptique parce que quand même, ça reste des modèles, ça reste des approximations. Et
il y a une chose par rapport au premier choc, puisque le premier choc a été localisé par le réseau permanent.
Oui.
D'accord. Et on ne connaît pas s'il y avait des forts chocs, par exemple, de magnitude vraiment.
Il y a un événement. Il y a un événement de magnitude 1.9 qui s'est produit 2 jours à l'avance. 2 jours à l'avance. Voilà. Parce qu'en reprenant la détection, j'ai trouvé ce petit événement.
Mais est-ce que ça, on peut parler maintenant on est dans un autre scénario?
Voilà, mais on n'a pas assez d'informations avant.
Et même la magnitude de conductance, donc la magnitude de conductance, elle va changer dans ce genre de. Parce que, non. Parce que maintenant, on avait un seul réseau permanent, et après, juste après le premier choc, on avait installé le deuxième.
Non, on a enlevé.
Et bien, voilà.
On a enlevé le réseau portable.
Donc, on a laissé. Non, mais est-ce qu'il ne faudra pas associer le réseau portable?
Non. Non, moi, j'ai complètement enlevé le réseau portable et j'ai repris du début la détection, utilisant seulement le réseau permanent.
Pourquoi?
Parce que si on prend, par exemple, la séquence comme elle était au début, le premier catalogue avec le réseau portable, je ne sais pas si je peux zoomer ici. Donc, on peut voir là qu'il y a un gros gap. Il y a un gap, parce que la détection des stations permanentes n'a pas pu détecter les petits séismes. Voilà. Après l'installation du réseau portable, les petits séismes.
C'est pour ça que j'ai dit par rapport à l'MC.
Voilà, donc on ne peut pas utiliser ce catalogue tel qu'il est directement. Parce qu'il y a un changement. Il y a combien? Au début, il y avait une vingtaine d'événements le premier jour, parce qu'il n'y avait pas de réseau portable. Donc, par exemple, si j'utilise ETAS, le modèle ETAS, on va prendre par exemple un exemple, si je suis ETAS, je prends ce catalogue. Je vais comprendre que le premier choc n'a pas généré trop de répliques. Mais après, il y a eu une augmentation. Et je vais l'interpréter comme un autre mécanisme. Mais alors, ce n'est pas un autre mécanisme qui était en jeu. C'était le réseau portable. Et lui, il n'a pas d'information de réseau. C'est pour ça qu'il faut refaire, que j'ai refait complètement la détection seulement avec le réseau permanent. Parce que comme ça, il ne peut pas être utilisé.
Mais on a vu le nombre de répliques qui diminue.
Oui, il diminue, mais généralement. Oui, c'est vrai, mais même si ça diminue, si on reste dans les 500, 400, grâce à ces modèles statistiques, on reste bien.
La séquence était à 1029, je pense.
2000. 2800. Non, mais 2800, avec des résultats complètement biaisés, grâce à cause de cette petite partie, je préfère avoir peu d'événements, mais être sûr.
Non, mais quel est l'intérêt dans ce cas d'installer un réseau portable?
Pour détecter les petits séismes. Mais mais de préférence, par exemple pour quelqu'un qui fait des statistiques, ou même
on va voir un petit peu l'étendue des failles comme ça.
Voilà. Mais
par rapport à ETAS et tout, et à l'étude des l'utilité. Est-ce que vous n'avez pas, par exemple, si vous utilisez un petit peu les deux MC, après vous avez...
Non, j'ai testé, ou par exemple, je commence par le premier. Déjà, le réseau portable ne s'est pas installé directement. Il y avait une station chaque 3 heures. Et ça, il faut le prendre en considération aussi. Parce que déjà, installer une station et attendre 4 heures, une autre station, 4 heures, une autre station, etc. Ça aussi, il faut le prendre en compte. Donc, j'ai testé les deux cas où j'utilise seulement la période où on a installé le réseau portable complètement, mais ça ne marche pas parce que l'information d'avant, elle est trop petite. Par exemple, si on utilise le modèle ETAS comme learning period, la période d'1 jour où on n'a pas détecté avec le réseau portable, la période est trop courte pour lui donner d'informations. Donc, on ne peut pas utiliser tout le catalogue tel qu'il est.
C'est ça l'intérêt de densifier notre
voilà.
Mais bien sûr, ça va bien. Ça va bien. On a donné de l'argent, il va y avoir une centaine de stations. Voilà. Donc le réseau permanent, c'est très très important. Et même le réseau aussi aussi important. Quelques petites remarques un petit peu sur le résumé en français.
Oui, oui.
Parce que bon, il y a eu, je ne sais pas comment ça s'est fait la traduction, des petites erreurs, bien sûr, même l'étude, c'est avec I, c'est pas avec un accent. Il y a un truc, l'échec de Coulomb.
Ah oui.
Monsieur Coulomb a échoué à donc c'est la chute de Coulomb.
Oui, oui, voilà, voilà.
Juste par rapport à un truc concernant l'événement. On parle de l'événement même, c'est toujours dans le résumé en français, l'un des événements sismiques les plus importants dans le nord-est de l'Algérie. Important sur quel
En termes d'événements.
En termes d'événements,
nombre d'événements.
d'études, bien.
En termes d'événements et d'études.
Non, mais important, on va dire que par rapport à ça,
ah oui, voilà.
Il faudra
ajouter l'information. Oui, voilà.
Par rapport à ça.
Je suis d'accord.
Voilà, je vous remercie, monsieur
Merci.
pour l'excellent travail. Donc voilà, ça nous a permis de discuter un petit peu
voilà.
sur quelques points. Et je vous souhaite plein de succès. Je sais qu'il y a pas mal dessus. Donc vous allez soutenir et on va essayer maintenant de le translater sur des trucs mais voilà. Vous serez sur le plan administratif, vous serez Inch'Allah d'ici septembre confirmé, je pense. Voilà, merci encore.
Merci beaucoup. Merci beaucoup, monsieur.
Merci, monsieur.
Merci, monsieur. Avant de donner la parole à notre membre de l'équipe, j'ai cru entendre de la part de M. Benzouli l'approche déterministe. Est-ce qu'il y a deux approches qui sont utilisées?
Ici,
je ne sais pas.
Non, il y a une approche déterministe. Oui, il y a les deux, mais là, ici, il n'y a pas d'approche déterministe. Là, c'est probable. C'est probable.
Donc, il y a des gens qui utilisent
déterministe, oui.
C'est comme la mécanique quantique.
Ah.
Non, mais en mécanique quantique, maintenant, il ne reste que l'approche probabiliste.
Voilà.
Einstein n'était pas d'accord, mais il n'a pas donné d'alternative. Juste une petite remarque avant d'oublier. Qu'est-ce que vous voulez dire par isotropique et anisotropique? Isotropique and anisotropic distribution of networks. Quelle est la différence?
Bon, le modèle isotropique, donc on assume que l'occurrence d'un sisme dans l'espace est la même partout et dans toutes les directions. Alors que l'anisotropique, non.
Donc, le point de vue calcul est beaucoup plus simple.
Ça simplifie le calcul. Ça simplifie le calcul. Le modèle isotropique simplifie le calcul.
C'est comme dans le monde de l'infiniment petit.
Voilà.
Jusqu'à présent, en ce qui nous concerne, on utilise tout ce qui est isotropique. L'isotropique, c'est beaucoup plus complexe.
Voilà. Ah, c'est pour ça que même aujourd'hui, c'est complexe d'inclure dans les modèles des trucs anisotropiques.
La physique atomique,
il y a des collègues qui travaillent sur l'anisotropie aussi, sur la vie qui travaillent sur l'anisotropie.
Bien, je donne la parole maintenant à votre collègue, M. Taki, c'est ça. Je vous en prie.
Est-ce qu'il y a des étrangers qui sont en
Oui.
I appreciate the work, maybe it's from the radio study based on statistical analysis, broadly speaking, using probability to have some feedback or insight into signatures in general, especially schools.
Yes.
So, first of all, I would like to discuss the structure of the manuscript and the way it was prepared. The first key point is simplicity, crafty, and short, argumentative sentences, scientifically speaking. If this is done, it will be very easy for reader to answer. And it's my secret. I don't say it was difficult, but I had some trouble to understand quickly. And all the job of all the studies. So, I think maybe you can improve the way you present the results and you analyze or discuss the results. And the key point here is just to be not important or can be understood using other aspects. For example, if I can just do one sentence, I will not write the second one. Maybe it could be understood from the first sentence, or just I will refer to something. Why? Because sometimes the reader is lost inside the document. And more we understand, more we can discuss, and more your job will have better value, something like that. So I appreciate the work saying seriously. In the presentation and materials, illustration inside, and some scientific point. I missed maybe some scientific point inside one. In the next, we are a little bit lost. We would like Mr. Rahmani go directly to the result, the goal, and give write few sentences explaining the problem. And for this, I would like to ask you a question. Simple question. Maybe here there is one page in which you illustrated different seismicity signatures, including swarm. I don't remember the page, but you illustrated the standard nature aftershock sequence and swarm like type, and another sequence with foreshocks. I missed the page. And my question is very simple. Yes, it's yes. My question is very simple. All the job done was focusing on characterizing the first seismicity signature of swarms and dynamic patterns inside, and to link afterward to the physical process clearly happening. And if I can understand, you analyze maybe a set of swarms. How?
You want to
explain to us the feedback from your study. How do you think these swarms in Algeria can be characterized or have some common signatures, or are linked to some typical process in the northern Algeria or something like this? Because this is very important for
yes.
And it should appear very clearly in your
Yes. So you want me to start from the first, or just simply? Okay. Because I like complicating things a little bit. I know that, but still. So here, if we take the swarms that we have detected, we linked each of them to their process according to previous studies. Only previous studies. We didn't use our study to understand which mechanism. Since some of them we have small number of events, and some we have the problem of incompleteness, etc. So we can't use some techniques properly to understand them. And yes, it's important, since we know that swarms can be precursors to big earthquakes. Also, fluid, mostly the ones that we have found are related to fluid, and are near the Biharon Dam, or we have the BMN sequence with the hydrocarbons and everything, which we could find the proper mechanism. So there are studies recently also that says maybe for swarms, for example, that are linked to fluids, which are the main ones here in our study. Linked to fluids, sometimes we have a fault, and fluids will expand this fault. And this expansion will in the future generate a bigger earthquake. Even if we know fluid generates small earthquakes, small to moderate. But in an active fault and with the fluids involved, this will expand the existing fault and generate bigger earthquake in the future. So here's like the storms that we have detected are related to fluid infiltration. So this is an answer you wanted, or maybe
You just your proper feeling after finishing the work. How? I'm asking the question. How can you characterize the northern Algeria swarms? I'm speaking about the seismicity significance and the dynamic patterns. This is your
yes. So we thought
is there any common aspect?
there is a common pattern. There is a common pattern which is the occurrence of more than one large shock. One large shock in a few days. If we take the Bnei sequence, we have 10 days, 3 large shocks. Bnei Ayn 5 days, 4 large shocks. And then when in 2 years we have 2 large shocks. So this is a common pattern. Yes. So this because even when detecting the swarm, we added another condition. It's written in the manuscript, which is that the magnitude of the largest shock and the second largest should be less than 1.
This is the best law.
Best laws greater than 1. But for swarm type, we assume smaller than 1, since they should, the first large shock and the second large shock should be near in terms of magnitude. So the swarm, most of the swarm detected follow these conditions. So this is a common pattern for all the swarms. That 2 main shocks, 2 large shocks or more happened in a short time. This is pattern, recurrent pattern. Also the clustering behavior in space. They are clustered in space, and some of them, for example, if we take the Mila sequence, we have a cluster in August, a repeated cluster in the same region in December of the same year, etc. So all these swarms have the similar patterns in terms of signature. What we found.
Yes, because at my knowledge, swarms, how to say, include different physical processes involved in their generation process. And if you can characterize swarms in northern Algeria, maybe you will have some idea about using the hazard ideas.
Yes.
So my second question is, you use the statistics and probability, and you use some kind of physical model. And we know ourselves that those two processes should be how to say, processed or applied not independently, just together. When we analyze the statistical probabilities, we just link directly to what is happening in the physical process. So I don't know in your job, but I said you have one part speaking about statistics and the second part discussing the physical. Although those models are different, but always when we use statistical analysis and modeling, we just discuss inference linked to the physical process, not in reality what is happening, because you know a lot of errors and in distribution process. I don't know how you tackle this issue, but it's very important to see in your manuscripts.
The linking between.
They are merging together for the physical process is appreciated in view of your statistical results. I don't know, but I felt he also you used the clustering.
Where?
Two things you use the clustering
Yes.
and you use Abbas.
Yes.
You know, the problem with the clustering is we don't have in the scientific community unique definition.
Yes.
What is
Main shock and after.
background and what is called linked or aftershock. It's based mainly on the proximity in space.
In time and space.
And in view of that, what I linked myself, because I studied the clustering for many years, is that we have to link the physical process just to have the feedback and to see if the clustering is
Well done or not?
being well applied.
Hmm.
The clustering is also a problem because we are taking out a
Part of the catalog.
the part, and this process is important. So when we can do the job without the clustering, and that is my way. For many years, sometimes we can just.
No, but for this study, for the analysis of the sequence you're talking about, the Newman seismic sequence. No, but I didn't use declustering to study the b-value and the omori. I studied the whole sequence above the magnitude of completeness.
Yes.
Here
Where you use the clustering?
Here, the declustering is not really to separate them. It's only to observe if I have how many background events I have in this catalog and link them after that to the tomography. This is the link that we wanted to do with the declustering.
So it's that you use declustering
Yes.
because we have background with probability.
Yes.
And that is the problem.
Yes, but it's not declustering then studying. Declustering and combine it and compare it to the tomography. That's all. This is the link, physical linking that you are talking about. So using the declustering and compare it to a physical process, which is here, tomography, and here we compare the two results.
You have to be very careful.
Yes, there's a slide talking about the impact of declustering on the b-value. And I talk about, of course, we lack now from an objective criterion for a main shock after shock. Yes. And here also, this is why this explanation, I think it's this slide where I did the test. Yes. Here I wrote it here, the impact of declustering. So I acknowledge this problem and I wrote about it in the thesis. This is why for both studies, even the last ones, detection of swarm, I didn't use declustering at all. I detected the catalog as it is above a certain magnitude of completeness.
And also the application of ETAS, and you know that the problem with the ETAS is that it is a kind of model that just go to the sismicity and the hypothesis is a branching process. And there is a lot of problems. It doesn't consider, for example, portions. When there is portions, modeling using ETAS is problematic. This is first. And the second problem is when you discuss your results, you just discuss the impact on the parameters, on the estimated parameters. Estimated parameters are after the modeling process. So usually we discuss impact or uncertainty, including the clustering on the physical aspect. That is the reality we are observing. I'm just trying to approximate this physical process. So the impacts here are, if an ensemble were discussed on the, for example, the value estimation and mass
productivity
and so on. But process of influence process after modeling, and there is some hypothesis linked to estimation. So maybe you can add some work to discuss the impact, uncertainty impact, or methodology impact, including the clustering on the physical process. It will improve your outputs. You use a lot of synthetic sismicity, especially in the first part theoretical part. But how to say, my point of view is to use real sismicity. This is the same point. Real sismicity.
No.
If we can. I saw maybe some illustration. Look, I did myself. Always I try the maximum, my best, to use real systems because it includes some technical process, but it's not covered by the modeling or estimation parameters. So if I can use the true sequence, it will be better. If I cannot, I can just illustrate as it is in some figures using how to say scientific systems as well as simulation.
Yeah, simulation, yes.
It's just done in statistical speaking, especially when my sample is full or I don't have enough data or I have a model and I cannot do the inference or testing, so I just generate from the model, simulate from the model. But for illustration, it's better to use real specific.
Well, for this case, I wanted to, just because at the first years of my PhD, to test this model and to code this model, I started with synthetic, so that when I estimate at least these parameters, I'm the one that gave these parameters. So I need to find the same ones. So I tested these models and tried different, like it's written in the manuscript, different like cases, especially for the magnitude of completeness, which take big part. This is why this chapter is clearly just problems about estimation. Yeah.
Yes, I understand well, but at that time you had the real system.
I have, yeah, it's
So this is just advice, it's not very important. So
that's okay.
how to say some some people vision or colors are
Yeah. Ah, okay.
My last question, you say from your results, you can have some insights into seismic harm and something like that. But you detect it in how? Well, I cannot understand maybe.
Okay.
How do you study how you use your results just to interpret
For the seismic hazard. Yes.
and
So for the first result, which is the study of Needleman sequence. So here, what this study can contribute to the seismic hazard, since we assume now that fluids are involved. This also should be taken into consideration for seismic hazard, since it's not a really typical main shock aftershock sequence, which for the ETAS model, using the ETAS model, it's easy to forecast using only the ETAS model. But here, for example, like now we have fluids, the importance of fluid on seismic hazard, if it reduces the stress or increase the stress in the region, we still don't know. So in that case, it's clearly because of the occurrence of the third class shock that is related to the fluid and the increase of the seismic activity. This should be taken into consideration seismic hazard in terms of like how it will affect the stress in the region and how it will affect the occurrence of an earthquake in the future.
because usually we came up with more than one scenario.
Yes.
And in this
Yes.
especially in your analysis, using
this work. Congratulations to all.
Thank you.
In terms of form, there is almost nothing to say. The manuscript is very well written. Everything is clear. So the chapters are very well chosen, and the illustrations are clear and of excellent quality. So in brief, the presentation of the manuscript is almost perfect. The only the only black spot is in the bibliography section. In the bibliography section and the presentation of references, which is sometimes poorly done. So, for example, when you cite PhD thesis, you will need to add the university where
university where it's
yes,
where there was a defense.
University where the thesis was done. For
Yes.
example, Abbas,
Yes.
Belgium, etc. So,
Harbi, yes.
some references do not include the pages of or the number that identifies these references. Some references do not contain any information. For example, in the Cherish 2017. For example, I didn't understand the meaning of PMID, so please remove this information. It's not necessary. And when you wrote the publication, you had to respect the standards of writing references one by one. So you should do the same with your PhD dissertation. And please avoid using editing software, which produce disastrous results. So in brief, you need to standardize your
references.
the presentation of references.
Yes.
Part of the manuscript, so it's often forgotten.
Yeah.
So this part is important. And now with regard to the substance of your work, so chapters 1 and 2 are very well written. I am not a specialist in all the mathematical aspects in developing the two chapters, so I won't comment of them. But however, I have confidence in what you have presented, given the scientific rigor that is clearly evident in the way you report the information, for example, quality references, illustration, etc. So I congratulate you on this remarkable job. I am going to concentrate my comments on the geological aspects of the chapter 3 and 4.
Yeah, okay.
So, page 96 and 97. So, at the beginning of chapter 3, you state that Nord-Eastern Algeria is characterized by two types of seismic sequences. You then illustrate these two types with examples from Japan. So my question is, don't you have example of the same patterns in the literature, but for Nord-Eastern Algeria?
Since they are the one detected, since they are the one detected in this study, so I started with an example outside, so that after, do not repeat after talking about the same thing at the beginning, because after that we need to use this technique to detect them, to see that this is clearly a swarm type event that has the condition that we applied. So at first I didn't want to assume that this is a swarm, this is not a swarm. I took a previous study and then conducted our own study and say this is a swarm in this.
So because if you illustrate this part with Algerian example, this status can be confirmed. Another question about figure 3.1 is the sequence main shock after shock. So is it the same earthquake? So the same fault which ruptured several times in the same area?
The same fault. Same fault. Like we have a main shock, a source will, and then the static stress transfer in this fault will generate this aftershock.
page 100, figure 3.2, the figure 3.2 must be enlarged. The writing is not visible at all.
Okay.
You must do enlarge your figures. And in figure 1B, figure 3.2, I think the Africa-Europe boundary should be a little further north.
Yes,
Your,
that's
your
right.
illustration.
That's
In
right.
the west of Algeria, I don't think it should be in the interior. Boundary of between Africa
Okay, it should be northern, yes.
So, so in the bird references, 2003, I can find in Africa, Eurasia, border, North Africa. So perhaps we need to look at more recent
publications.
references for and the D, the figure D, is there references for this figure? So the reference for the magnitude shown must be given.
Which one?
Figure 1D. 3.2D.
3.2D. Which one? This one.
This one, yes.
The last one.
Yes.
No, it's ours. It's ours. We use the catalog. This is the magnitude above the magnitude of completeness that we have determined from the catalog. Maybe I should write the CRAAG data.
Could you say this? This is the research of.
The magnitude of completeness, yes. Yeah. No, we did it. It's a new figure.
It's a new one.
It's a new because.
In the page 98, you state on page 98 that the seismic sequences in Nord-Eastern Algeria are of the 2 or more main shock type. So perhaps you need to be more precise in relation to the figure 3.1. So is this the tip represented in figure 1D or 1C? Or, so it is the swarm tip or main shock after shock sequence.
So this is the recurrent pattern that we observe in 3 large shocks in less than 2 days. So this we can assume from the technique that we have done that they are so. But there are few of them that didn't.
Here you need just to
specify
if it is the tip 1C or 1D
okay.
or precision.
Okay.
And in page 99, what do you say this clarifies why we have in,
Which one?
90, in page 91, 99. When you see the Asnan earthquake, you say after that this clarifies why we have focused our attention on the northeastern region of Algeria. Page 99.
99.
When you see the Asnan earthquake, first paragraph.
Picture. So when we talked about the Asnan earthquake, right? Yes, because from the west region, first of all, we only observe large earthquakes, like Asnan one. Only on the north and east where we observe these patterns that we talked about, the patterns of various large shocks and this clustering behavior in time and space. This is why maybe this needs more details written so that it will be more clear. for the reader.
Because your work are focused on
Nord-Est, swarm type. This chapter is focused on the swarm type.
So in figure 3.14, page 114. So here you need to add the months of the Al-Qantur earthquake. So you need to
January and November, and the January.
Yes. Al-Qantur earthquake, because in 2020 there was another sequence in Al-Qantur, so in January. So
separate between both of them. Yes.
So you may also need to add aftershock fluid earthquake of small. And so you mentioned also on page 113 that the 2017 Al-Qantur earthquake coincided with the seismic crisis.
Yeah, in time.
So you should therefore state this on page 111 and suggest the possibility that the seismic crisis was due to a dynamic stress transfer from the Al-Qantur main shaft. So, also, this is not the case in all the pages. You please cite the months or the day months of the new earthquakes.
Okay.
Because so to be precise, you need to specify the day on which the most important earthquake took place. But for example, when you say on page 115 that there was dynamic stress transfer for an Awana to Al-Qantur events in January 2020, you need to specify the date of the start of the Al-Qantur crisis, so that it can be compared with the start of the Awana crisis and see if there is a real relationship between the two. So you need to specify the date of your earthquake. In page 117, figure 3.60, you should have changed the title of the figure and written it in your own way. So, for example, in this chapter, you have used the same phrase
for the figures.
Command and all publication. And reading this gives the impression that it is your work that it's being referred to.
Yes.
In this chapter, you use
the same for the figures title, right?
Of others.
Yes.
You should.
I thought about using that
your own
way and put the reference, but the reference is already done. So I thought about writing it and put the reference.
In page 118, you mentioned that the origin of the C18 swarm is a creeping phenomenon associated with sea sport. Why do you say that?
18.
On this swarm?
The publish.
The C18 swarm. You say that it's a creeping phenomenon.
Wait till I find the C18.
Page 118.
Yes, no, I'm searching for the cluster. Which one of them? I'm searching for the cluster. Which one is the C18? C18, okay.
The first paragraph.
C18. 118.
Yes,
the first
paragraph.
C18
swarm.
Both potentially source triggering many settings could be attributed to creeping. Instead, specific modes, microseismic occur almost constantly in the region. observable recorded preceding the recent. So we observed before 2007 also small events, even if there was not used. When we are talking about creeping, we are talking about like type of temporal behavior where there is like an, let's say, stairs. Stairs, like one event, stairs, one event, one event, one event. This is why we attributed this. We observed this kind of phenomena, but I acknowledge that we didn't put this figure on the manuscript and should be given.
There is no studies before.
What?
There is no studies.
No, there is no studies before.
This is your
From our observations.
What do you mean by aseismic sliding?
Seismic sliding. It's like movement, but without the occurrence of earthquake.
So for this chapter 3, it is important to summarize this chapter in a table. So listing all the swarms and
yes.
also the origin of each swarm. So
yes.
This is as well as all the important information about each swarm. So
yes.
you need to summarize this chapter
in a table. Okay.
Page 132 and the other page also. So you see work that is still under review and then details what has been done. So I have noticed that you see articles in your thesis that have not yet been published or accepted. So you should never cite the results of unpublished.
Yes, okay.
So you could even say that work on the subject is in progress. So,
okay.
For chapter 4, for alien swarm, so this same remark as a figure needs to be figures needs to be enlarged, and there is another aspect of this in this chapter. So this is independent of the seismology. In addition to the scientific aspect of this study in chapter 4 related to seismology, there is a new aspect related to oil exploration. So your study indicates for the first time the existence of large hydrocarbon reservoir in the region, so which could be sort of interest to oil companies. So this is, I think that this is an important point in this study. So, l'existence d'un réservoir pétrolier dans la région, c'est peut-être, ça pourrait intéresser des compagnies pétrolières. Je dirais que indirectement, vous mettez, c'est-à-dire vous avez mis en évidence l'existence d'un réservoir pétrolier. Pourquoi vous êtes, bon, là, vous indiquez que peut-être que c'est autre chose. Pourquoi vous dites que c'est un réservoir d'hydrocarbures? Hein? Est-ce que vous êtes sûr de ça?
Bon, il y a des rapports en 1990 qui disent ça, qui sont intéressés par la région de Moussa. D'ailleurs, lors de l'installation de réseau pour Paris, à l'époque, dans la géo, ils ont installé des géoponts, là-bas.
Non, je pense que c'est réellement un réservoir d'hydrocarbures. Surtout que la région, de toute façon, il faut se rappeler que le premier gisement de pétrolier algérien, c'est pas au sud, là, c'est en 1949, c'est au sud de Guéra, c'est ouais, de Terre. Voilà, c'est le même contexte géologique. Et donc, je pense que bon, ce résultat, il pourra être peut-être avec l'étude des swarms, des essaims sismiques, donc indirectement, on pourrait mettre en évidence l'existence de réservoirs pétroliers. Ça pourrait être utilisé par l'exploration pétrolière.
Nous avons aussi une thèse sur la méthode de l'esteemed pour bien résoudre la résolution verticale. Donc, il y a le marquage, le premier article allemand.
Voilà, donc je pense que tu pensais très bien. Je dirais que, en plus des résultats scientifiques et liés à la sismologie, on a aussi peut-être aussi un résultat
physique
qui pourra être utilisé dans le secteur socio-économique en relation avec l'exploration pétrolière.
Oui.
C'est un résultat remarquable. Voilà, donc merci, thank you again for your remarkable work, and I wish you all the best.
Thank you.
Donc, on va essayer de parler parce qu'il y a des gens qui ont en train de parler. Donc, je passe la parole à nos invités, monsieur Yanis. Dans l'ordre de la thèse, monsieur Ferhat.
Salam alaikum. Tout d'abord, je n'ai pas grand-chose à dire parce que nous en laissé à dire. Mais juste, j'ai beaucoup apprécié votre travail, le temps que vous avez fait déjà rédigé en anglais, ce qui est une très bonne chose. Vous avez touché à une problématique quand même qui est assez compliquée. C'est vraiment pas complexe parce que vous avez touché. Vous avez touché un petit peu à toute. Il y a une bonne partie où vous expliquez un petit peu toute les mathématiques et tout qui se réfère à ça. Moi, je n'ai pas vraiment grand-chose à dire, sans vous féliciter.
Merci.
Et vous dire que votre carrière de chercheur commence aujourd'hui. Tout ce que vous avez fait en tant que doctorant. Là, vous allez être chercheur et là, vous allez commencer vraiment à faire beaucoup plus de recherche. Je vous souhaite tout le courage et
Merci.
tout le réussite.
Merci.
C'est tout ce que vous avez à dire.
Ok, merci. Donc tout d'abord, je voulais m'avoir invité à cette thèse, dans la mesure où, bon, je suis à gauche, donc je suis avec les membres qui ont lancé un peu cette aventure concernant un peu ce type d'études. Aussi, je vais être un peu bref, mais je tiens à féliciter M. Rahmani dans la mesure où il a su reprendre le flambeau et aller de l'avant dans l'interprétation et dans la compréhension de ces études qui ont été menées maintenant depuis un nombre d'années. Tout le monde est en train de me regarder avec des yeux de mélancolie, mais je ne sais pas pourquoi. Alors, bon, donc je vous félicite.
Merci.
Et c'est d'un niveau vraiment d'un haut niveau, et j'ai aimé l'aisance avec laquelle vous avez écrit le document, mais aussi présenté. Donc, toutes ces félicitations laissent augurer, d'après le modèle des TAS, une future carrière de chercheur prometteuse.
Merci.
Ceci étant, quelques petits remarques.
However,
Si vous permettez.
ça c'est comme les reviewers. Les reviewers, c'est un bon travail, however.
Je fais partie de cette aventure. Malgré que je suis retraité, j'aurais pu dire je suis retraité, donc il n'y a plus rien à dire. Mon ami ici présent par Ferhat me dirait quand même honorer ton rang. J'ai bien aimé au niveau de la présentation, vous permettez que je
Bien sûr, vous avez le temps.
Ah, d'accord.
C'était une parole en l'air.
Alors, bon, moi j'ai bien aimé, vous avez parlé de coupable. Alors, est-ce qu'on a attrapé le coupable ou pas?
Supposé coupable.
J'ai l'impression que vous avez mené, on a attrapé le coupable.
Non, mais ça.
Moi, j'ai l'impression que le coupable, on vient juste à peine de le serrer. Parce que, franchement, c'est un coupable, mais qui est.
Supposé coupable.
On ne sait pas très bien.
Non, mais ça, c'était
Et
beaucoup
puis, les
plus
coupables,
comme
ils
un
sont
piège.
nombreux.
Ça, au début, c'était comme un piège.
Les coupables, ils sont nombreux.
Non,
Ils sont nombreux parce qu'on voit la complexité. Chacun se comporte d'une façon. D'accord. Lorsqu'on a démarré sur cette région, et moi je suis venu à Sétif, je suis venu avec une seule information. En 2006, un séisme en 419 à Sétif. Le reste. Et depuis, l'eau a coulé, les fluides ont coulé, et on on a eu toutes ces informations qui nous ont permis, effectivement, alors d'avoir une image actuellement de la sismicité et la question, l'une des grandes questions, avec Essam, vous voyez des premiers ténors, et je remercie et je les félicite parce que là, ils reprennent le flambeau. Aujourd'hui, ils sont là en termes de directeur de thèse et de co-directeur de thèse, et qui, eux, sont on part avec déjà cette idée que une bonne partie de la sismicité algérienne se présente et se passe à l'est de l'Algérie. Et on voit ces swarms se développer. Alors on se dit, est-ce que naturellement, avec cette étude en utilisant, je veux dire, ETAS et toutes ces techniques, est-ce que ça devient là la panacée? Parce qu'on commence à se dire, est-ce que la référence, nous, c'est le séisme que nous fait la semaine, permettez qu'on fasse une petite discussion. I'm sorry, colleagues, maybe in English, but anyway, we have to discuss in French also. À l'Ouest, ça ne se passe pas comme ça. Alors, si aujourd'hui on a des swarms, est-ce qu'on est conforté dans l'idée que ça peut se passer comme ça? Ça se répète. Mais est-ce qu'on peut se dire que finalement, bon, sur la rupture, puisqu'on essaie de comprendre la rupture et comment ça se passe, et c'est là où on essaie de comprendre notre enquête, puisqu'on est des personnes qui font enquêter sur l'objet du crime. Mais est-ce que ça nous conforte dans l'idée que on a souvent des swarms qui se manifestent? On est de temps en temps assez étonné de voir un bni-humain se passer, parce que bni-humain, bon, magnitude 5, moi magnitude 5, j'arrête 2-3 jours plus tard, il y a d'autres magnitude 5. Oh, bon, c'est bon, tu t'arrêtes. Et une semaine après, il y a encore une magnitude 5. Mais c'est la première fois que ça se passe. Et donc, on se dit, est-ce que là, on commence. Alors, pourquoi toute cette sismicité arrive? Pourquoi on a tous ces essaims qui se. Est-ce qu'on a vraiment, je veux dire, réussi à se dire, puisque quelque part, c'est d'anticiper sur ce qui va se passer ailleurs. Puisqu'en fait, il faut se dire que tout reste à faire aussi dans cette région. Tout reste à faire.
Ah oui.
Je pense. Alors, moi, ces questions que l'on se pose, j'aurais souhaité, et je souhaite, beaucoup d'étudiants avoid un chapitre qui est important, c'est discussion générale. Et discussion générale, j'ai cherché partout sur une thèse, c'est important. Parce que non seulement on va discuter, là, on parle
des deux registres.
Magnitude, on doit parler d'abord des réseaux, de la qualité. Pourquoi on va installer un nouveau réseau? On a besoin d'avoir de l'instrumentation. On a besoin d'avoir de l'information. Si on n'avait pas d'information, on ne serait pas fait. Donc l'importance
du réseau,
d'ouvrir
la densification,
ça se discute, c'est tout un pan de la discussion. On l'évite. De voir comment les lois d'Omori, on ne sait pas, je discutais à l'époque, est-ce que c'est comme ça que ça va se passer? Je gère une crise. J'ai un sinistre, j'ai appelé votre. Ah oui, la dernière fois c'était mis alors qu'elle avait un glissement. On a passé une semaine en crise pour savoir comment ça allait se passer. Est-ce que finalement nous avons le déclin ou pas? Et ça, je ne vois pas pour des ans. Bravo à la collègue, hein, mais ça, je vous parle en termes de par rapport à quelqu'un qui a du recul. Mais ça doit apparaître dans un grand chapitre de discussion. Pour ensuite, je veux dire, mettre en exergue des points, parce que on a l'impression que oui, c'est bien, on a attrapé depuis le temps. Vous le mettez, alors moi, ce que j'ai bien aimé dans votre thèse, c'est qu'à un certain moment, il y a des passages, oui, mais on n'est pas très sûr, que vous vous remettez en cause. En ce moment, on doit se le mettre en cause.
Ah, c'est
On doit
sûr.
absolument se le mettre en
Parce que
cause.
ça reste des approximations. Donc,
Ça reste
des approximations. Donc, on n'est pas
fait
sûr.
des tasses pour bien comprendre. Est-ce qu'on est dans la complétence, on essaie d'étendre, on met des zones.
Après, on combine plusieurs
Tout à l'heure,
informations et on
est-ce qu'on
va.
peut extrapoler? Je ne pense pas. Je ne pense pas qu'on puisse extrapoler. Je ne pense pas. La physique et la physique, la tectonique active, la géologie, on découvre chaque jour. Ou sinon, le débat est lié à la paire. Moi, je demande à midi, à la présentative, j'ai l'impression d'avoir tout découvert. Non, les jeunes, tout reste à faire. Il y a un sujet très complexe. On n'a fait qu'un petit client. On se parle que le classe c'est parce qu'un Bernard sur l'adresse au Bernard, pour essayer de comprendre le rôle des fleurs. Donc, les flux qui m'ont fait, je suis là. أنا أولاد قلت لي أوكي عسكر كما قالت سي لو بروميير بس راح له بس قاعد قلت لي ولا ماشي طلبت الماء قلت لي يا ولد خلينا وبنحكي لكم واحد سيربيا اكتسب بالاخر قال Non, il faut faire ça. Vous avez toutes vos carrières devant vous. On est là, hein, on est dans un début d'approche de ces comprendre. Et ce qui va se passer dans le futur, là, Jaya, c'est un cas d'école. L'offshore, il est à côté de moi, la chance, on ne va pas discuter. Oui, mais bon, parce que. Et donc, oui, la couverture du réseau, l'installation des réseaux, ça discute, ça discute, c'est ça le chercheur. C'est ça le chercheur, il ne faut pas penser que voilà, bien. Félicitations, bravo, c'est une excellente thèse. Il y a beaucoup d'humilité. Chauffe un des retraites, je viens avec en toute humilité, parce qu'on n'a fait qu'un chouïa. Bravo à toute l'équipe, voilà, avec toutes ces personnes. Alors, même chapeau, avec sismologue, avec sismologue, c'est pas la donc, les figures neuves, les corrigées, on a fait Monsieur Benjoudi, on est CRAAG, on a la couverture, question fondamentale. Je ne peux pas, moi, ça fait partie de l'invité, parce que j'aurais été peut-être, je fais partie, page 9, page 10, page 3, on arrête. Je viens avec d'invité. Heureusement. Non, voilà, il faut
D'accord.
y aller. Inch'Allah, voilà, beaucoup de trucs. Inch'Allah, peut-être, effectivement, après un certain temps, on a essayé du tout. C'est-à-dire que ça fait peur, mais ça fait pas peur. Quelque part, bon, c'est une science, on essaie de comprendre. Mais ça, Inch'Allah, puisque l'impact social est important, Inch'Allah, justement, de ces ruptures. Parce que même les discussions sur les transferts de contraintes, sur comment se comporter, souvent on a de. Ça, tout ça, ça doit apparaître dans les discussions. C'est ça qui est important. C'est ça la physique, c'est la physique chose. Vous êtes des physiciens, physique de la rupture. Et ça, vous avez déjà donné, on a travaillé surtout sur les paramètres du interstitiaire, on a des valeurs, on n'a pas. Avec un déchet zoning, il aurait fallu discuter. Oh, ouais, il a présenté une excellente thèse. Monsieur Kharoubi, l'offshore, on a qui m'a c'est énorme. Et tout ce qui est venu après, c'est quelque chose qui nous apporte à chaque fois son lot de surprises, mais la compréhension de la physique est toujours remise en cause. Toujours remise en cause. Et c'est ça qui va. كيفاش الكتالوج لازم يحصل على الكتالوج كاين انا نعرف كل بعض كلام بعض بصح كلامه انا اللي parle de 1716 ou 1410 peut-être j'ai rien passé peut-être non انا quand j'étais petit personne ne m'a parlé d'ici dans la base كنا لاباس علينا merci d'avoir. On a dit que يعني c'est une peut-être il y a peut-être des gaps sismiques. Le mot gap, je manage انا كي جيت في فيزيكا بوستام وهذاك الحباب تاع كذا لا ما قلنا le mot gap fait partie de la physique. Comment s'initie la rupture par rapport à quoi?
C'est une bonne norme.
Elle voit loin. On va rester le débat à la base de toute une vie. Mais la sismo, voilà, donc c'est toutes ces personnes, ces jeunes, c'est pour ça qu'on vous forme, pour aller vers. Mais faites attention. Ce n'est qu'un pas, parce que la sismo algérienne, c'est un laboratoire à ciel ouvert. On a la nana à l'est. Qu'est-ce qui se passe à l'ouest? Qu'est-ce qui se passe sur le plateau? Qu'est-ce qui se passe sur Buscara? Parce qu'il y a des trucs. Qu'est-ce qui va se passer à Berdaya? On ne sait pas. Transfert de contraintes, c'est de la physique et de la physique et de la géologie. La géologie, du de maintenant, c'est complètement différent.
Pardon, si vous permettez aussi, alors je reprends aussi que, par exemple, d'un point de vue géologique.
Oui.
Si par exemple, vous l'avez dit, alors si en Algérie, les séquences sismiques à l'est algérien donc, sont différentes, le type A est différent de celui de l'ouest algérien. Là, j'entrevois ici, c'est-à-dire une cause géologique, c'est-à-dire la géologie à l'est ou à l'ouest,
donc j'en termine. Officiellement, Monsieur le Président et Monsieur Bijoudi, je fais une demande officielle de refaire une thèse d'un art par rapport à la pour la suite avec critique. Merci à vous, la technique. Et désolé, bon, mais j'espère que finalement, on va faire.
Merci, monsieur. Donc, ce qu'on va faire maintenant, parce qu'il y a des gens qui assistent de l'étranger.
I don't know if...
Ah, d'accord. Je vais donner la parole au
directeur.
Voilà, pour intervenir et à la fin, on va conclure avec nos invités.
Un petit mot, je vais laisser demander ça un peu plus. En particulier, je vais remercier tout le monde aujourd'hui pour cette discussion et surtout la direction du CRAAG représentée ici par son directeur général Jody, le directeur de division études sismologiques Raouri et l'ancien directeur qui est angulaire de cette équipe. Je le remercie surtout pour faciliter l'accès aux données qu'on a utilisées en particulier dans cette étude ou utilisées dans toutes les études. Et ça pour contribuer à réduire le risque majeur auquel notre pays, l'Algérie, est exposé. Sinon, pour Sofiane, je te souhaite beaucoup de succès dans sa carrière future, que ce travail soit le début d'une longue et brillante carrière scientifique. Merci pour ce travail.
Merci.
So, first of all, I extend a welcome to our colleagues joining us from abroad. So, welcome everybody, welcome everyone. Second, before starting to talk about the thesis and the candidates, I want to express my profound gratitude for this opportunity to be here today with you, dear professor. Each of you holds a special place in my memory. First, Mr. Weber was the initial guide in physics, probably in quantum mechanics during my first university years. Also, Mr. Chateau and Mr. Khadoubi were respectively examiner and guest in my during my PhD thesis in 2015, and it's an honor to say the continued application in the defense of my PhD student together. Also, Mr. Judy, the director of CRAAG, respect his obligation and occupation is presented as today, where I remember the first script in GMT, first answer, and for modeling, but I learned from him during our work in the meta traces in the numeric experience. Also, Mr. Aldi, the symbol of statistical analysis technology in Algeria. Finally, Mr. Willis, supervisor of my magister thesis, then my doctoral thesis, where I discovered of him the pleasure of research. And happy birthday.
Thank you very much.
Yes, happy birthday for him.
It's a summertime. For retiring, it's good.
So I wish to express to you all, dear professor, my utmost appreciation, respect, and regard. Now, talking about the thesis, so indeed the extraction of spatio-temporelle seismic characteristics in northeastern Algeria began in 2012-2013 as a part of my doctoral thesis, where I addressed two fundamental statistical laws, the Gutenberg register law and the inter-event time analysis. This led to identify 9 seismogenic zones. So this first step then inspired the development of the new thesis in the subject with my friend Walid. Then our enthusiasm was reinforced where Sofiane chose and accepted the team. Especially we had already supervised his master, and we are aware for strong potential that he has in both physics and mathematics to essentially explain for this research field. Now, throughout the thesis, he was keen to understand each statistical parameter and provide the more complete earthquake catalog, starting with the completeness magnitude, which is essential for any statistical study.
6 months.
This step took him more than 9 months of hard work to be able to determine it using 4 different approaches. And which
The problems, the
work,
issues and problems with the data.
which give a very similar values. And also, of course, using non-stationary FAS model with the time varying background. And he demonstrated a high ability in programming, mathematical analysis, and physical interpretation. Moreover, he established a super collaboration with distinguished scientists around the world, starting with Mr. Bogdan from Kyoto University in Japan, who visited him to work together in the forecasting problem or forecasting topic. And he is also a co-author of one of his works. Then Mr. Hansel with him in the Germany GFZ Center. They are actually developing the PhD model. And also Mr. Marcel, the owner of the code used in the principal article. And finally, Mrs. Crispo from Madrid University, who with whom
we worked in this paper.
We worked together in the ELN paper. Also, without forgetting his wonderful relationships with his colleague from GFZ training, He collaborates with them in several scientific works. So this demonstrates the strong teamwork that defines him. As a result, Sofiane for me is a complete researcher in both technical or artistic aspects. Artistic, yes. Yeah. He is also known by his strong defense in his ideas. I remember sometimes the discussion between us would reach a point of shouting and
Stop talking for 2 months or something.
And in the end, we were, of course, happy to find the accord between us. So, it has been always a pleasure to work with him. And finally, I'm very, very happy for these results. I'm very happy for your son. Congratulations and good.
Thank you.
Just the last point.
Much.
I would like to thank the technical team for their support. Yeah, Abdul and Taki. I would like also to thank all the colleagues of Sétif, Michel, Zahir, Mehdi, Khalid, Arabia. Also, I would like to thank Mr. Zian for his facilities that he provides to Sofiane. Voilà, c'est terminé. Monsieur Aken, c'est le président.
D'accord, donc c'est le tour juste un truc qui nous donne une petite information pour les collègues, monsieur les soucis, et ça n'est pas si directeur de recherche.
Ah ouais.
Félicitations.
Bravo, bravo, bravo.
I don't. Yes. So, if one of you has a comment or a question, okay. Yeah, but I don't think they will. Yeah. Normalement, oui.
Donc, we would like to thank our colleagues who are attending this dissertation virtually from abroad. So, everybody is welcome to add any comment or simply to participate to this discussion.
I think nobody. Ah. Non, bah, je pense pas. Je pense pas. Activer le son. Là, non. Puisqu'il y a le message, واحد ما هضر. Donc, non. Non. Non, non. I hope. Well, Sofiane, congratulations. Comments, and some of them just went maybe the internet or something, or they didn't hear. Okay.
D'accord. Donc, pour conclure ce débat, donc, à mon tour de féliciter M. Rahmani qui était avant tout mon étudiant en licence. Voilà, à partir de là, il est parti ailleurs. Donc, je suis.
Vous l'avez licencié. Vous l'avez licencié.
Non, il a été ouvert dans le bon sens du terme.
Dans le bon sens du terme.
Il était entre le bon sens. Voilà. Donc, je suis content qu'il fasse partie de cette équipe avec mon collègue du CRAAG. Sincèrement, je ne savais pas qu'ils ont atteint ce niveau de recherche. C'est vraiment, cela fait plaisir. Donc, j'ai été honoré de faire partie de ce jury. Donc, je félicite encore une fois M. Rahmani et nos amis du CRAAG pour ce qu'ils font. Voilà. Merci à tout le monde et maintenant
délibération.
Oui.
Oui. C'est juste pour souligner aussi, tout à l'heure, bon, M. Abbas l'a dit, c'est un petit peu, bon, personnellement, j'avais commencé la thèse de Abbas en 2015, j'étais jury de sa thèse, et depuis, bon, j'ai fait partie, je ne sais pas, de 5-6 jurys de thèse, c'est la plus, et aujourd'hui, là, en 2024, presque, bon, 10 ans après, je ne sais pas, il y a eu peut-être une dizaine de thèses qui ont été soutenues en sismologie, et pour moi, là, je pense que c'est vraiment, il faut quand même le souligner, c'est d'abord, c'est un petit peu la réussite de cette formation doctorale, une très belle formation doctorale, je dirais, qui ont donné à une production qui m'a allé. Alors, pratiquement une thèse par an, donc par mois, il y a une dizaine de thèses, et donc pour moi, c'est vraiment énorme, et on le voit aussi de la qualité des publications actuellement qui sont en train de paraître à l'équipe de Nord-Est, donc il faut quand même souligner.
C'est deuxième génération, c'est deuxième génération qui est en train de faire. Son directeur.
Ah oui, de toute façon,
la façon 89,
voilà, donc je remercie l'équipe de Sétif. On a vraiment l'émergence d'une équipe de sismologique et c'est vraiment une équipe.
C'est longtemps sportive de sismologie. Le SS, attention, sismologie. Alors, on va toujours plus au football.
Donc, merci à tout le monde. Et donc, maintenant, le jury va délibérer. Donc, nous prions à l'assistance de rôle.